Hello and welcome. This is Rashid Khan and you're watching my YouTube channel. In this video, we'll be going through some exam questions together. The question says, which of these is the equation for work done? Now you need to recall work done has an equation which is WD is equal to F times D. And you have to recall they must be in the same direction. Now I'll look at the four options available to me, and the one that will be similar to what I have here will be my answer. The first one says work done is force divided by distance. So this is wrong. That's wrong. Next one says work done is force times distance moved in the direction of force. So this is right, and there's everything in this equation seems correct. So the answer is B. Next question says figure 6 shows a book resting on a table with some forces involved. So I've got a table and I've got book. So there are two objects involved. So state why this diagram is not a free body force diagram. If you remember, we discussed free body diagram will have forces must be on the same object. Forces must be on the same object. Now in this case, you can see here there are two objects and the forces are acting on two different objects. We can say the forces shown are on two different objects. Next question. A student investigates moments of forces. Figure 14 shows the apparatus used. You can see here there's a pivot here, there's a rod, some modeling clay. This modeling clay will make it rotate clockwise, whereas this magnet will make it rotate anti-clockwise. It says the pivot is under the center of the rod. A magnet is fixed to one end of the rod. A piece of modeling clay is fixed to the other end of the rod. The system is in equilibrium. So the moment I see this, this means that clockwise moment and anti-clockwise moment, they are both equal. The moment I see this, then it reminds me that anti-clockwise moment must be equal to clockwise moment. Now it says state the relationship between the moment of the weight of the magnet and the moment of the weight of the piece of clay about the pivot. So what I'm going to say is I can say this one is F1, this one is D1, this is I can say D2, and this is F2. I'm going to say F2 times D2 is equal to F1 times D1, and that will get me the mark. Next question says figure 1 shows some forces acting on a seesaw. The forces shown have the same magnitude but act in different directions. In which of these could the forces acting on a seesaw be in equilibrium? In equilibrium. So it's a seesaw. So again, clockwise must be equal to anti-clockwise. Let's have a look. So in this case, this will make it turn anti-clockwise, and this force will also make it turn anti-clockwise. So it will keep on rotating. If I look at the second option, this will make it rotate anti-clockwise, but this one will make it rotate clockwise. And if the two are in opposite direction, then they'll cancel out their effect. The only option that, so B is the correct answer. My answer is B. Next says an electric motor is used to lift a box. Figure 4 shows how the efficiency of the motor changes as the box of Figure 4 shows how the efficiency of the electric motor changes as the mass of the box increases. Describe how the efficiency of the motor depends. Describe how the efficiency of the electric motor depends on the mass of the box lifted. Now in this case, I can clearly see here the efficiency is going up and then it is decreasing. So all I have to say is I can say as mass increases, the efficiency increases. But this is up to mass equals how much? So you can see it goes up, and it's almost up about here. So I can say this is about 25 kg, up to mass being 25 kg. Then I'll say as mass goes up, efficiency decreases. This is after mass equals 25 kg. And that will get us both the marks in this case. Next question. A cyclist is riding a bicycle at a steady velocity of 12 meters per second. So this is the value of v. And says steady speed means it's not changing. The cyclist and bicycle have a total mass of 68 kg. So that is the value of mass. The cyclist starts to cycle again. The cyclist does 1600 joules of useful work. So this means this is the value of work done. To travel 28 meters is the value of D. Calculate the average force. Now for this case, what is happening is, here is the cycle. The cyclist, it tells us the cyclist does this much joules of work to travel 28 meters. So this means from here to here, this is 28. And when it comes to this location, it now has 1600 joules of energy. And they're asking us to work out the value of average force. I'm going to do equation WD equals force times distance. The amount of energy is 1600. The value of force is not known, but the value of distance is known, which is 28. You divide both sides by 28. This will cancel out and it'll give you a value of force in newtons. Next question. Fuel weighing 230,000 Newton is pumped into an aircraft. The fuel moves upward to a vertical height of 4.7 meters. In other words, they're saying 4.7 meters. That's the distance the fuel travels. And the weight or the force involved is 230,000 Newton. The power developed by the pump is 1600 watts. So this is the value of power. It says calculate the time needed. We do not know the value of time. In this case, we can say our equation will be power equals energy divided by time. How much work has been done? We can calculate. Force times distance. So I can then say power equals F times D divided by T. Once I've done this, all I have to do is I can then just plug the values in and solve, and it will get me to the answer. So power has a value of 1600. The value of force is 230,000. The value of distance is 4.7, and we do not know the value of T. You can put 1 in the denominator. You can cross multiply and try to work out. You'll end up with T being 230,000 times 4.7 over 1600. If you plug it in your calculator, it will give you the answer in seconds. Next question. This figure 6. The figure shows an arrangement of gears. Each gear turns around a fixed axle. Gear P is turned through 1 complete revolution per second. So they are saying P turns, the speed here is 1 rev per second. Which of the following describes the motion of gear R? I'm going to say that P is turning clockwise. If P turns clockwise, then Q will turn anti-clockwise. And if Q turns anti-clockwise, then R will turn clockwise. So P and R, they both have same direction. Number 1, they both have same amount of teeth as well. So if you remember, I gave you equation. It was the speed of gear A times the size of gear A equals speed of gear B times size of gear B. In this case, they both have same sizes because they both have 10 teeth. They will cancel out. So VA will be equal to VB. Which of the following describes the motion of gear R? So gear R has 1 revolution as well. Why? Because the number of teeth. Gear R will also have 1 revolution per second speed because it has the same number of teeth. So this is right, this is right. The only thing that's wrong here is it can't be opposite to P. It has to be in the same direction. So this is correct. The answer is B. Next question, what they've done now is they've replaced this R with a rack. And they've given us some information that the teeth on the rack are 2 millimeters apart. Calculate how far the rack moves when P turns through one complete revolution. So when P turns through one complete revolution, this is equal to 10 teeth. The distance between the two teeth is equal to 2 millimeters. So I can say the distance will be 10 times 2, which is equal to 20 m. Next question. This is an important question, so make sure you are paying attention while I'm going through the answer to this question. It says figure 3 is a diagram of forces acting on a swing. The swing is not moving, so it is resting in this position. The seat of the swing AB is 0.80 meter long. A person of weight 450 newtons sit on the seat. The person's weight act at a distance of 0.50 newton from A, as shown in figure 3. So this is the value of weight force. It says ignore the weight of the seat. The upward force exerted by the ropes on the seat are F1 and F2. Calculate the force F2 by taking moment about A. By taking moment about A means A is my pivot. So if A is my pivot, then this force is passing through A. There is no distance from the pivot for this force. So this will get to a value of 0. So the moment produced by this force will be 0. I just have to say, because I can see now, I just have to apply the principle of moment because it is not moving, so it is in equilibrium. I can say clockwise must be equal to anti-clockwise. Now this force will make it turn clockwise, whereas this force will make it turn anti-clockwise. When it makes it rotate, and when this force makes it rotate clockwise, we can work out its moment by saying 450 times by 0.50. For the second one, I can do F2 times 0.80 because it's 0.80 meters away from it. Now, if you solve it, you'll divide both sides by 0.80, 0.80. This is gone. You'll be left with the value of F2 in newtons. And that's how you work out the value of force using principle of moments. Next question. It's figure 8. It says figure 8 shows a bicycle. The rider uses the pedal to make the larger gear turn. The rider uses the pedals to make the large gear wheel turn. The large gear wheel moves the chain. The chain turns the small gear wheel. The large gear wheel has 48 teeth. So this is the value size of large. The small gear has 12 teeth. So this is the size of small. So here you have 12. Here you have 48. So the larger gear turns 2 times each second. So it is 2 rev per second. Calculate the number of times the small gear wheel turns each second. So we can say this is X revolution per second. So we said speed A times A. So in this case, it will be 12 times X equals 48 times 2 because that's the size. So we said size A times the speed A equals size B times the speed B. And that's what I've done here. So if you do that, you can divide both sides by 12, and if you solve, you end up with the value of X, the revolution per second. So this will be the value for the revolution per second for the smaller gear. Now it says oil is applied to the wheel of a bicycle at the point shown in figure 9 here in the axle. Explain how the oil improves efficiency of the bicycle. So first thing, what I'll do is for a 3-marker question like this, I'll write down the expression for the efficiency. So this is equals useful over input. So I can say in this case, input is equal to fixed. It can't be changed. We will not change this. Number 2. Now, what will oil do? Oil will increase useful by reducing wasted. Why? Because oil will reduce friction. Next question. A drone has a mass of 4.5 kilograms. The value of M. The drone rises from the ground to a height of 20 meters. This is the value of H. It says calculate the change in gravitational potential energy when the drone rises through a height of 20 meters. So we need to work out GPE equals question mark. They've given us the value of G as well. 2 marks is straightforward. All you have to do is GPE equals M times G times H. There are no unit conversions required for this question. Straight away plug in the values and you will end up with the answer. So what has happened in this case is the drone was here. Now the drone is at this height. So when it is at this height, it will have this much GPE. Where did that GPE come from? We can say this was the work done on the drone that it raised its energy from 0 GPE to this much GPE. The next part now says calculate the amount of useful work done by the blades as the drone rises through 20 meters. So it's going to be the same answer, same value just taken from here. Now it says it takes 4 seconds, so this is the value of time, for the drone to rise through 20 meters. Calculate the useful power developed by the blades in 4 seconds. We looked at equation power equals E divided by T. Remember, in one of the last questions that we did, we also worked out energy or power. Last question on this worksheet. Figure 13 shows a toy that a student makes for a nursery school. For a nursery school, the rod hangs by a string from the ceiling. So they've given us different objects, 1, 2, 3, and they are all hanging on the meter ruler. So you have to be very careful here because unit conversion will be required. Number 1 and number 2, distance calculation as well, or I can say distance measurement. The moment of C about point P is 0.60 Newton meter. So this is the value of M. Let's calculate the weight of C. So weight of C means F is not known for C. They've given us the equation. Now, in order to use this equation, I need a value of D. Where am I going to get this value of D from? I'll have to go back to this side. So this is my fixed point. From this fixed point, C is at a mark which is 10 centimeters. Now I can't use distance in centimeters, so I'll have to do conversion. So I'll have to say from 10 to 40, this is 30 centimeter, which is same as 0.3 meter. So I'll put these values in this equation. I can say this is 0.60 equals F times 0.30. We divide both sides by 0.30, and it gives you the value of F being equal to 2 newtons. Next part says show that the total moment of S and R about P is 0.70 newton meter. So total moment. This means moment due to S and moment due to R. We have to add them both together. So we've been given the value. We have been given the weight of S and R. So you can say S is at a distance of 10 centimeter, whereas R is at a distance of 50 centimeter. All I have to do is use equation for the moment. So this will be moment of S plus moment of R, and this will be my total moment. So moment of S will be worked out using F times D. The value of force is 2. Distance is going to be 0.1 because I have to convert it into meters. Plus moment due to R will be the mass of R. The weight of R is 1 Newton times by the distance, which is 50 centimeter, but I have to convert it into meters, so it will be 0.50. If you plug these in your equation, you will end up with an answer which will be equal to 0.70 Newton meter. So far what we have done now is we have seen the moment of C is how much? 0.60 Newton meter. But the moment of S and R combined together in the other direction, which is clockwise, together is 0.70 meter. That's what we have worked out here. Now the next part here says, using the data in question and the principle of moments, determine if the toy shown in figure 13 is in equilibrium. So we said for it to be in equilibrium, this must be equal to this. So we can then say, in this case, for this question, I can say anti-clockwise moment is less than clockwise moment. Why? Because the anti-clockwise is 0.60, whereas this one is 0.70. therefore it is not in equilibrium. Remember, you'll get 1 mark for this, 1 mark for this, and 1 mark. So make sure you do state this, that for it to be in equilibrium, this condition has to be satisfied. This is the end of this video. I hope you'll find it useful. I wish you all very good luck with your exam preparation. Thank you.